are working with these pennies. So each team of 2 people is going to receive a set of pennies. The year of minting is written on the box, but it's your job, because every year it happens, to check that the minting year is correct. If you have in your box a minting year that is incorrect, bring it back to me and then I will distribute that, okay? Okay, so what we're doing today is the following. First, we're using the analytical balance to take some pennies at the time. We cannot put all of them in the balance because they are very heavy. And we're putting groups of pennies, you need to know how many, in the balance. We tear the balance, we put the pennies, we record all the significant figures. Remember that for the analytical balance, the number sig fig after the decimal point are 4. You need to record all 4 for accuracy of your measurement, okay? So we divide the pennies in portion. We know how many we are putting every time, so 2, 3 portion in the balance. We weigh them. Then we add all the masses of the pennies and divide that number by the entire number of pennies. Okay? What does it mean? That we are going to measure in that way the average mass of 1 penny. Okay? So that's what we are going to do. And we're doing this with analytical balance. Then what we are going to do, the next step, is we are going to use water displacement to perform the measurement of the volume of the pennies. So when we're doing water displacement, we are going to use a 100 milliliter graduate cylinder. We're going to put some water. So here is our graduate cylinder. We are we're using 100 milliliters graduate cylinder. We are going to put some water. We are going to read the meniscus of the water, pointing our eye exactly where the meniscus is. We record this first volume. Then we pour all the pennies in here, and the new volume will be rising to a certain value. Let's say that the new value is going to be here. By subtracting from this value that we are going to read to the third significant figure, this value from this value, we obtain the volume of all the pennies at once. Then we divide again by the number of pennies that we have in each container, okay, in our container, and we obtain the average volume of the pennies. We saw a problem in class in which we were working on water displacement, right? We are doing the same type of calculation. After that, we are going to report, I'm going to prepare an Excel table for the class in which each team is going to write their name, the year of minting, the mass, the volume, and the density that you're going to calculate in grams per milliliter in class for your minting year. Okay? Then I will collect all this value and email it to you so that you can make 3 graphs. One in which you have the mass versus minting year. One in which you are representing the volume in milliliters, this is in grams, versus meeting here, and one in which you're representing the density versus meeting here. Okay? So you're obtaining in your post-lab calculation 3 grams. You have to comment on the accuracy and precision of the overall measurement from the class, because it could be that in theory the mass should be always like this, no changing in theory, or maybe there is a change, we don't know, but you need to see, is the mass consistent? Do we have accuracy, so it's close to true value, and precision? Or do we have values that are like this? So we have systematic error, or what is the other type of error? Random error, correct. Same thing for the volume, same thing for the density, okay? So you don't have to mention the name of the people that might have made a mistake, right? But you have to mention what is the meeting here, where if somebody did the measurement wrongly. In your conclusion, you have to report what is the source of error, what could be the source of error, what could be the source of error in your measurement of the mass, for example. What could it be? Not closing the doors of the balance. Another error?
Putting too many.
What's that?
Putting too many.
Putting too many. Another error? Carlos?
Not tearing the balance.
Forgetting to?
Tear the balance.
To tear the balance. Third source of error. For the volume, what could it be the source of error? Not feeling?
Yeah, just say like you added 60 millimeters every single time and
So you're saying no filling with the initial water, the granite cylinder? I wouldn't say so, because you're doing this only once. You're filling the granite cylinder with certain amount of water. You add the pennies and you read it. That's it. It's only one measurement. Okay? Because all the pennies will fit in the granite cylinder. So it's a one-time measurement. No, what is another source of error? I have an eye here. I'm going to put another eye here. What could be the source of error?
I guess measuring the wrong one, or
Right. We don't read accurately the volume. This is a very common error. This is one of the most common error, number one. Number two, we might not read the correct number of significant figures. Remember that when we are making measurement, there are a certain number of figures. They are called certain, because we can actually read those. You have to read to the first uncertain figure. And that is done by, you remember we said that we take the granite cylinder and we have the volume of the water that is, for example, here at this mark, and between these 2 points we divide the volume, the space in 10 parts. You remember? We talked about that in class. So 2, 4, 6, 8, 10. And we leave to the interpretation of you, operators, to determine what is the last sig fig. This variable, okay? So make sure that you know how many certain figures, significant figures, you have in your volumetric, in your graded cylinder, and then I leave to your interpretation the last one. So oftentimes a problem that we have in this lab is that students don't use the correct number sig fig, and so they lose in accuracy information.
So in total we have 60 pennies of the 2013
Good.
minting
What
year.
about you? Are you ready?
So our first step is going to tear
Remember, you
the
can
analytical.
leave it up unless I sign you off. Means you have to have my signature on your data.
Now, for the first batch, we're going to have 20 pennies of the 2013 year. We're going to put it. And then we're going to put them back.
I'm sure it's more
Okay. Now, we're going to get the second batch of 20 pennies from 2013. We're going to put it back and we're going to close it all the way. Now we're going to get the final batch of the 2013 minting year pennies. Just another 20. And then we're going to shut it completely closed.
Plus, he cannot be that your volume has 2 sig feet. For me, has more. So restart again.
Now we're gonna start.
Just brought 2 sig feet in here.
Turn it off.
Okay, restart.
So this is for the 1972 minting year of the pennies, and we have 35 in total, and I've split them up into 3 batches. So first we're going to be doing is setting up our analytical balancer. So turn it on, and then we're going to place our vial in, close the doors completely, and then we're going to tear it. Now we're going to put our first batch of the 1972 minting year pennies. We'll put in 15. Now put them back. Close the doors shut. Now we're going to put the next batch of pennies in. It'll be 10 of the 1972 minting years.
So you need to try your pennies and restart again.
Put the next 10 in. Now we're going to put the last 10 pennies of the 1972 minting year. Now, we just tar it. Let me shut it off. So we're going to be determining the volume of the 2013 minting year pennies. So first we're going to be adding some water to the graduated cylinder. Now we record the volume of water to the correct number of significant figures, and then we're going to add the pennies. Now we're going to be adding all of the 2013 minting year pennies to the graduated cylinder. Now we record the volume of the water along with the pennies to the correct number of significant figures. So after recording, we're going to take out the pennies from the graduated cylinder and then dry them until all the water is mostly off of them. Now that the pennies are dry and free of water, we're going to put them back into their vial. So we're going to be adding water to the graduated cylinder for the 1972 pennies. Now after recording the measurements, we're going to add the pennies. Now that we've added all the 1972 minting year pennies, we're going to record the volume to the correct number of significant figures. And afterwards, we're going to remove the pennies and then dry them completely and put them back in the 1972 vial. So now we're going to calculate the average of the mass by minting years. First, we find the total mass of all the pennies per minting year by adding the recorded masses. Then we divide the total mass of pennies by the total number of pennies to find the average mass of a single penny of that minting year. Now to calculate the average volume by minting year, we subtract the final reading of the volume after adding the pennies from the initial volume of water before adding the pennies. Divide the volume obtained for the pennies by the total number of pennies to find the average volume of a single penny of that minting year. Then use the average mass and the average volume of the penny for each minting year to calculate the average density of each penny of that minting year. Finally, report your name, the minting year, the average mass of one penny, the average volume of one penny, and the average density of each minting year in the Excel spreadsheet provided by the instructor. Using the collected data for the entire class, create 3 graphs. The first is of the change in mass over the years. The second is of the change in volume over the years. And the last is of the change in density over the years.
So at this point, you write under this column your team name, first name and last name, the minting number, the minting year, the average mass that you did calculate, the average volume in milliliter that you did calculate, and then the average density that you calculate. What I will do is I will compile all this data and provide it to you on Canvas, and then you will use the minting year, the mass, the volume, and the density data to generate 3 graphs. And what you will do is you will check if the average mass stays the same over the years or if there are changes. Same thing for the volume, same thing for the density. And you will make comments in your conclusion about the accuracy and the precision of each data point collected. You will make comments on the accuracy and precision of the average density, and you will make observation on how the mass and if the mass, the volume, and the density change over the years. That will be part of your conclusion.